In this video, we're going to be looking at solving equations with variables on both sides and looking at some special cases that can happen occasionally and can sometimes mess you up. So let's start with a problem. And we're back to selling pretzels and looking at our market research. So suppose a company is researching sales of pretzels in two separate towns again. The table below represents how many bags of pretzels have already been sold in each town and the rate at which the two towns buy pretzels in bags per day. After how many days will the two towns have bought the same number of bags of pretzels? So we are basically looking at the same problem as the last video, and if you didn't check that, it was using Graspable Math. But the thing we're looking for again is we're looking for days until the towns have bought the same amount. And so we have the bags of pretzels that have already been sold. We have the average bags sold per day. So we have kind of a rate going on here. We have our starting amounts. And we're going to see when these two towns will be the same. So I'm going to define a variable here. We'll say x is the number of days, because that's what we're looking for again, is the number of days. And like before, we're going to look at town A. We're going to look at town B. So let's see. So for town A, we're selling 100 bags of pretzels per day. So 100x plus, so 100 times the number of days. So every day we're adding 100, plus the 1,200 bags we started with. And then for town B, we've got 100 bags sold per day, so 100x plus 800, the amount they've started with. So we've set up two equations. This one talks about how much town A has bought. This one talks about how much town B has bought. So we're going to set them equal to each other. So looking for when they're equal. So we're going to look at our steps and think about, okay, there's nothing to distribute. There are no fractions, so I don't have to worry about it. No combining like terms, so I'm going to go straight to moving my variables. Let me change colors here. I'm going to go ahead and move this 100x. So I'm going to subtract 100x from both sides. And well, when I do that, I know 100x take away 100x is 0. Those cancel out. So it's 0 plus 1,200 equals, well, same thing over here. 100x minus 100x is 0 plus 800. Well, we know that 0 plus anything is just itself, so I get 1,200 equals 800. It doesn't take long to realize that this looks weird. We can't say that 1,200 equals 800. We know that, we can count. So something's not right. Well, let's think about it for a moment. Look at how many they start with. Town A starts with 1,200. Town B starts with 800. But how many do they sell per day? They both buy 100 bags per day. One town isn't buying faster than another, so they are going to constantly have a gap between them. Since they're buying the same rate, this town will always have more if they continue in the same rate because they're gaining the same amount every single day. So if we're using that logic, these two towns will never be the same. And this can happen sometimes in real applications. Sometimes equations won't equal each other. So these two towns will never have the same amount of pretzel sold, which is okay. There's nothing wrong with that. It's just something that happens. So let's dive into this idea a little bit more. Let's look at another equation. So we saw the pretzels that they didn't work out. Let's see what happens when I do this one. So I'm going to go ahead and distribute on both sides. So I'm going to solve like we normally would. So let's see, I get 4x minus 20 equals 4x minus 20. Okay, so I don't have any like terms to combine on either side. So when I move this, so minus 4x minus 4x, I get negative 20 equals, well, that's 0, so that's gone. That's 0, so that's gone. So I have negative 20 equals negative 20. Now this is another weird case. We saw before where we had 1,200 equals 800. and we determine that they'll never be equal, what does it mean when we have the same number equal to itself? Well, that's a great question, and there's a new word for that. This is what is called an identity. Oh, let's back up here. So this is called an identity. So an identity is when an equation is true for every possible value of the variable. I'm going to write the first step in here while you get this definition. So this is an identity because when I see at the very bottom and I get negative 20 equals negative 20, negative 20 is always going to equal negative 20. This is a true statement, and that's part of solving equations, is we're looking for a number that when I plug it in, it gives me a true statement. And if I look at this step right here, 4x plus minus 20 is always going to equal 4x minus 20. This side is equal to that side. So if you ever get a situation where you have the left side is equal to the right side and you still have variables, this is called an identity. Now, another way to say it is you can also say your solution is all real numbers. So you may hear it called an identity. You may hear all real numbers, meaning you can plug in any number for x, and this statement is true. So this deals with the second funny case we looked at, but what about the first case we looked at with the pretzels? Well, that's a good question. Let's look at it with an example. So I'm going to solve this problem. So I draw my little divider here, my brick wall, and I'm going to distribute. So I get, let's see, 3x plus 4 equals 3x minus 3. And I see here my variables are the same, but my numbers aren't. I have a 4 and I have a negative 3. So when I move my 3x's, 3x minus 3x is 0. Same thing on this side. I get 4 equals negative 3, which is the same situation that we had with the pretzels. Now, in that situation, we had a solution of never. They will never work. So the term that we're going to use is we're going to use no solution. We're going to say this has no solution. You may say never, you may hear no real solution, but this will never be true. This side will never equal that side because when I cancel out my x's, I'm left with 4 equals negative 3, which is never true. So to kind of summarize solving equations, there are really only 3 possible outcomes when it comes to solving equations. So the first one is when you get just a plain number answer. And this is all the other videos that we have. You'll get x equals 3, x equals negative 100, something like that. That's your first possible outcome. The second possible outcome is an identity. And that's when the left side equals the right side. So when you have something like 5 equals 5 or 2x plus 1 equals 2x plus 1, you can plug in any numbers. And so this is also called all real numbers. So you have that option. It's all real numbers. And then the last one is no solution. And so it's no solution when you solve and you get something like 4 equals 5 or negative 3 equals 100. Something like that where you have 2 numbers equal to each other and they're not the same. Or something like this where your variables match but your constants don't. So 2x plus 1 equals 2x plus 3. This has no solution. You can't plug in any value for x to make this true. So that's just a brief tutorial on how to identify the special cases for solving equations.